Can you grab the back door? We're good? Great. Hey everyone, how you doing?
Good.
How's CircleCityCon treating you so far?
Good.
Good? Good. Forgive me if I space out, I'm on a bunch of allergy meds, so thanks for coming. I know it's the last talk of the day. It's been a long day. I'm sure your minds are already full of a lot of information. So unfortunately, this one's going to be a doozy. It's I got 60 slides, so I got to follow like pretty quickly. I'm going to try to avoid the death by PowerPoint. I'm going to do a lot of talking. I do have like a 2-minute video demo, but again, I'll try to hustle through this and leave some questions toward the end. I'm happy to stick around afterwards if you have any follow-ups. So my name is Bryan McAninch. My talk's titled The FaaS and the Curious. So here's a quick agenda of what we're going to be talking about today. I'll go over a brief introduction about myself and where I gathered my sources of inspiration for this talk. A quick overview of FaaS, some of the AWS services that we're going to be concerned with, types of attack vectors, and then how it can mitigate some of those. So introduction. Again, Bryan McAninch, in case you already forgot. My hacker handle is Aphex. Grew up listening to a lot of Aphex Twin while I was coding, so Aphex. There's my Twitter handle, creatively named Bryan McAninch. I'm the founder and executive director at Pervade Cybersecurity. It's a 5-person startup in Dallas, also Pervade LLC. My background's in a variety of disciplines, as most of us probably are. Started off in pen testing, got into security architecture, digital forensics, and now I'm really focusing a lot of research on cloud containerization and trying to get into AI a little bit. And by that, I'm not talking about automated scripts, actually AI. So, again, inspirational sources here. So there's a gentleman by the name of Rich Jones. There's his Twitter handle. It's a gun.io. I think it's a security company that he owns, or is he maybe a partner of. He did a talk called Gone in 60 Milliseconds. He's done several iterations of them. Really good stuff. Kind of laid the groundwork for a lot of this type of research on AWS and Lambda specifically, or otherwise known as function as a service. Another gentleman named Andrew Krug presented last year at Black Hat Vegas. Saw him talk. His talk was titled Hacking Serverless Runtimes. Again, really good inspirational source. And then just want to give a quick shout out. I'm from Dallas. We have a really, really awesome hacker community there. The first one, North Texas Cybersecurity Group, Dallas Hackers, DC 214 DFW, and OWASP Dallas. Feel free to look them up on Twitter. They've got some really cool members and content. Alrighty, so getting to it. What is FaaS? So quickly, and just by show of hands, how many of you are familiar with cloud? Just generally speaking, cool. And then containerization and function as a service or serverless, cool, fantastic, right on. So a lot of this, again, I'll just do talking points because it sounds like you guys already know a lot about it. Serverless, as its name implies, is not actually serverless. It's containers running beneath an event-driven application. In this case, we're going to be talking about AWS Lambda, benefits of which are minimal cloud infrastructure to maintain, administer, configure, patch, et cetera. And because of that, it's minimal operational overhead. Growth estimates on this, valuation of 7.75 billion USD by 2021, forecasted to grow year over year at a rate of about 33%. So it's going to be a phenomenal growth here in the next few years. So what is FaaS? For those of you who didn't raise your hand, just describing that, here's some of the, from a business standpoint, some of the benefits of it. So on the left, you see the rack and stack, rack-mounted servers, to deploy and maintain. Time to deploy was days. Cost, agility, scalability, not so ideal. Then we moved into virtualization. We're trying to squeeze more out of those hardware resources by putting multiple VMs onto one hardware platform. And then somebody somewhere wasn't happy enough with that, so they came up with containers, Docker being probably LXC, LCX, actually, what was it? Was probably the first, but Docker's become more the predominant one. Now you've got Kubernetes and other variants and whatnot. So we can deploy those very, very quickly. They're transient state. Cost is low. Give it 3 out of 4 stars, and now we're looking at function as a service. millisecond, very, very transient, up and down, very minimal maintenance. It's pretty much you're pushing code out to this fully managed infrastructure, and it runs. Any questions so far? Cool. So AWS services. Again, I've done a lot of focus on AWS. I work with it pretty regularly. So quick overview of Lambda. Again, it's their function as a service implementation. This is just a description I ripped off their website, but the reason doing so is after reading that, hopefully you all have now, this is kind of what I pulled out of it, right? Runs your code on underlying compute with back-end services, and I was like, that sounds like a really good opportunity to start doing some research on how that can be manipulated and potentially abused. So again, not to kill you with death by PowerPoint, the big takeaway here really is with most containerization and particularly FaaS, it's stateless, it's got ephemeral resources, read-only file system. For billing purposes, again, because of the big benefits from a business and operational standpoint, Lambda will run for a minimum of 1 millisecond. AWS will charge you a minimum of 1 second. They have a maximum lifetime of 300 seconds. Again, scalable, it's monitored. AWS provides this X-ray service, they call it, to help you find resource utilization metrics, telemetry data basically on your code, right? It helps you find some bugs and stuff like that. And later on, I'll kind of allude back to that on how some of that might be tampered with. So high-level overview of what maybe like a Lambda architecture would look like. So on the left, you'll see, this is by no means a holistic list, but just an example of different AWS services that you can plug into Lambda, different event sources, if you will. So right there in the middle, you've got ECS, which is Amazon's Elastic Container Service. This is a bit of a presumption on my part. There's no documented evidence that this is actually how it is, but based on my research, this is my best guess, is that Lambda is actually running on an ECS EC2 cluster, and when it's invoked, fires up, bootstraps your code, fires up a Docker container, executes it, and then dies. And then behind the scenes, currently it supports Python, Node.js, C#, and Java, with plans to expand into, I can't remember what the other language was off the top of my head, but yeah, so quick example of how Lambda actually operates. So there at the input, you'll see kind of a JSON formatted key value pair. You can receive that from any of those other services or your own that you write. And on the right, you'll see the code. Again, it's kind of a hello world Lambda function, but it's basically just printing out the key value pairs, and then back down on the left corner, you see the output of that function, right? So it's saying loading function event key 1, value 1, et cetera, et cetera. So AWS IAM is I would say the foundation of all security in AWS. They have a very granular access control. It's what I would call more or less like a mandatory access control model, meaning it's denied by default. So if you go in and create a new user, they don't even have the ability to change their password or log in. You really have to go one by one and explicitly allow users and or resources to perform certain actions on certain resources. Just kind of brushed over that a minute ago. In the context of AWS, you actually have a user, but they extend that to include resources, so you can assign some of these roles and policies that I'll show here in just a sec. You can apply to EC2 instances, for example, and they can assume a role temporarily and execute whatever action is desired on an intended resource. Again, big takeaway is that the users, the accounts for that matter, are created with no permissions by default. No big news here, nothing special about a group. It's really just a collection of users with common permissions. You might have an admins group or a backup DRP group, something like that. Roles, as I just kind of mentioned, with EC2 instances and resources collectively or services, You can apply the roles. You can also do that for users as well. Those credentials are retrieved on an EC2 instance from the EC2 metadata or from AWS's simple token service. The policies are the point at which your access controls are actually enforced. So JSON formatted object defines explicit permissions against deny by default. They have AWS managed policies, so if you don't want to go anything or create anything from scratch, which is pretty cumbersome to do, they give you a nice template to work with. You can keep that one, or you can do what they call like a custom inline template. Maybe they give you a managed and you want one additional permission added to that, you can put that inline. Real easy to use. Extremely granular, which can be a double-edged sword. We'll get to that in a bit. But it, at the same time, supports entity wildcards, so that also tends to open the door for compromise at times. So this is an example policy. I am confused because they can get quite complex. This is a pretty simple one, actually. We have here an S3 bucket that we'd be granting access to. The bucket name is Colonel Sanders, the resource is called Colonel Sanders. Allergy meds. The resource is called KFC bucket. The principal that access it would be someone named Colonel Sanders. You can put conditions in there when they can access it, before, after, during, et cetera, et cetera. Any questions on that? I'm really flying by because I really want to focus on this section. Good? Cool. So just a quick disclaimer. Because I've been at a couple other presentations. I think most notably last year there was a DEF CON kind of side talk. I forget what they called it. I sat through it and I kind of was like, wonder how is he doing this? And it turned out all the appropriate permissions were already in place. And I was like, well, that's not really telling me anything. And the more I got to talk to him, the more I understood that, well, you know, he's got a point, is that due to their esoteric nature, and they're very fine-grained and they can become very complex, a lot of these policies become very lax, right? They need to troubleshoot something, they're going to insert a wild card, maybe they forget to change it back. So, you know, culprits include everything from serverless web service frameworks, automation tools for CI/CD deployments, third-party solutions, and untrained cloud admins, right? Maybe they've just assumed the role because they were promoted off of some other, maybe they were a server admin for on-prem systems and they're moving to cloud. They're doing their best, but they really don't understand the whole IAM thing, and it truly is its own science. So no fault of their own, but things like that do happen. So in terms of attack vectors, as you would do on any sort of research, penetration testing, engagement, anything like that, you know, first thing you want to do is really get an idea of what your target looks like. So we're going to go over some active reconnaissance techniques. We're going to look at how we can start hijacking credentials of the underlying Lambda container, what we can do that, and how we can do that, and how we might be able to abuse some of the permissions that have been granted through IAM. We're going to look at how we can gain persistent remote access through those means. And then we're going to look at reverse engineering the Lambda runtime environment. So they have a couple interesting things you can do with that as well. So curious minds want to know, because again, this is the FaaS and the curious, right? So it's a list here, but you know, anytime you're thinking about getting credentials, that's usually an attacker's dream. If you can get credentials, you can do local privilege escalation, you can do lateral movement. There's a number of things once you have credentials. As we'll see here in a minute, there's a couple things that AWS has put in place to try to prevent that, but there's also some workarounds from an offensive standpoint. So how can we abuse the credentials? What's the operating system, the network? A little further down, you'll see, how's our code bootstrapped? If I put in malicious code, how does AWS handle it? What data can we control once it's bootstrapped? And can we change the runtime execution flow? Because AWS has done a phenomenal job at locking down this environment, right? Getting ahead of myself, but kudos to them for what they've already done. There's just always going to be a way around something, right? If you've got enough time and resources on your hands, whether it's just a board hacker or a nation state entity, someone's always going to find a way around any control you've implemented. So first place I looked was AWS Lambda FAQs. It's like, what can I do with this thing? And I was really new to Lambda, and I was just wanting to kind of get, scrape the surface with Python, start coding with Python. I've done a number of other development languages, but never really jumped in and did anything with Python. So I was like, oh, this would be a really cool opportunity to learn a little bit more and apply it and do some research with it. So first question that I came across relevant to this research was, does AWS Lambda support environment variables? Well, yes, it does. So I was like, oh, that's cool. And you can easily create or modify, and let's remember that, from the Lambda console, CLI, or SDKs. Today we're going to be mostly talking about the Lambda web console, but a lot of it as well can be done through the CLI and SDKs. What restrictions apply? Now I found this really interesting, is Lambda attempts to impose as few restrictions as possible on normal language and operating systems activities. And I was like, well, that's awesome for the research anyway, right? Because that gives me a lot of flexibility on going in and profiling the underlying container. There are a few activities that are disabled. Again, they've done their due diligence. They're making sure that you're not sending out a bunch of traffic on TCP port 25 and sending a phishing campaign or something like that. So they've done some due diligence there. Can my application trigger an AWS Lambda function directly? Yeah, it can. In fact, we're going to go over how we can use Amazon API Gateway to gain some persistent remote access to the environment. But it says here you can invoke a Lambda function using a custom event through AWS Lambda's invoke API. Are you guys able to read this okay? Sometimes it's a little washed out with the light. Okay. Second one, how can I invoke a Lambda function over HTTPS? This is kind of alluding to that AWS API Gateway we're going to use. So we're going to use that to gain persistent remote access, but on top of that, it's going to be over HTTPS, and it's going to be difficult to intercept and detect. So even better for us. So I started this after reading. We control the environment variables. And I'm like, well, what kind of environment variables could possibly be in a Lambda function or the container underneath it? So again, I was really new to Python. This was last summer I started working on this. So I was like, well, go do some research on how we can kind of enumerate through Python what the environment variables are. And I just did a little very, very simple os.system, and you pass it whatever shell command you want to execute. I passed it ls. I just wanted to list the directory, see what kind of files are in there. ls was simple. I did a couple others. I started doing like cat etc password, a number of other things, and worked for about a month and then suddenly stopped working. So I don't know if that maybe triggered something. AWS is very good at staying on top of detecting attacks. I've done some scanning from my own VPC before going out to the internet, and they were on it like that. So chances are I probably raised a flag somewhere, or someone else did doing some similar research, and they now do restrict some of the os.system parameters that you can pass to that. So, but nonetheless, I said to myself, well, why don't we just dump all the environment variables? And again, I hope you can see this. I tried to break these slides up and make these as big as possible. But basically, you saw the example function earlier. All this really is doing is I'm printing out all the OS environment variables of the underlying shell. Right? So I want to get an idea of what those are. This is all through the web console. So this is the output that I got. Now you'll notice this orange arrow here is pointing to this variable called AWS session token. For those of you that aren't familiar with AWS IAM, we talked about users and roles and policies. They have this simple token service, and they grant this token to you for temporary access to resources, so that it's not hard-coded. You're not putting it into your code, or maybe it's a developer that has what they call a secret access key and access key ID. You can put it in your command line interface configuration file, and that will grant you access. This is a nicer way, a little bit more seamless way to onboard resources and users and grant access to them. Nonetheless, I looked at this and I said, well, we've got access to a session token for this container, and likely it's running with whatever IAM role that I've applied to it. And again, for purposes of proof of concept and research, I just gave it access, right? So go ahead and have access to S3 and DynamoDB and a couple other things, so I can read and write and just kind of see what parameters I could operate within. So I said, well, why don't we just go ahead and dump all the really cool IAM credential environment variables, and as you can see here, those are the names. We've got AWS Access Key ID, Secret Access Key, AWS Security Token, AWS Session Token. The security token and the session token are the same values. I don't know why that is, but I suspect they're going to probably phase out one for the other sometime in the future. But yeah, it returns the credentials at the end, and now we've got what you can see here. Don't get excited. These are already expired. You can't copy and paste them and go hijack my account. Alrighty, so there's some limitations with this, right? Because we're using a web interface and passing commands, and it's kind of a spray and pray approach. It's really inefficient. It got me to a really good starting point that I could kind of leap off of and do a little bit more research, but the best workaround, obviously, is to have some sort of interactive shell. And I'm like, well, how are you going to get an interactive shell, reverse shell? So I found a Python reverse shell script on, I think it was like Pentest Monkey. They've got a cheat sheet. Within a matter of minutes, I fired up a Kali Linux instance on my own VPC and had a reverse shell on the container that the Lambda function's executing on. Now the interesting thing, keep this in mind, is that Lambda lifetimes are limited to 300 seconds. So to go through and do this, you have to be a very quick typer, right? Your words per minute might be up there in about 200 range to really get anything meaningful. I was able to, cat etc password, if config, and things like that, and get a good understanding, but you really want to dig deep. You don't want to have to keep doing this over and over and get a reverse shell and log in. So I was going to show a quick video. Hopefully this will work. I'm not confident enough to do it. Yeah, cool, right on. So that's the reverse shell code that I just showed you. This is my AWS account. I'm just going to play it here. So you insert that, you can host name, IP, port. Right here I'm setting up the netcat listener in my Kali Linux instance and my own VPC. And I just executed that, and you'll see now the screenshot that I just showed you. Who am I? And now hopefully you can keep up with some of this. Can you see this okay? It's a little, okay. Okay, so what I'm doing here, I'll just pause as I go through this. What I'm doing here is cat etc password, I did a who am I. User that I'm operating under is called SBX_user. Thank you very much. SBX_user 1057. I'm like, that's an interesting username. What could SBX stand for? Any ideas? Maybe a sandbox user, right? Yeah, cool. So I was like, well, I wonder what's the login profile look like? Cat etc password. Or I grepped for that user in etc password rather, and found that it's even better. Awesome. It's still a little small, but that's good. That's not on you. That's on me. Yeah, you can't zoom in on this either. So by grepping for that username, you can probably see at the end of that line it says sbin no login. So clearly Amazon's not expecting me to be logged into this shell right now. You unpause this, take another step forward. I'm just highlighting the fact of what I just mentioned. So cat etc password. Now here's where things get interesting. See how many SBX users there are listed, right? So Amazon, the Lambda containers, again, they're transient. They come up and go down, but not all of them are new. So they have, and this is some research that the other gentleman I mentioned at the beginning of the talk have done. They've done some really cool analysis on like cold boot, warm boot of the underlying container, and some really kind of discrete artifacts they've discovered in their research. So I highly recommend looking at their work. But from what I can tell, a lot of these containers are reused. There's one place that you can actually write to on the file system. We'll get to that in a minute, but there may be some potential for abuse there as well. If there's I'm using a container and I write to it, and then someone else invokes that again, and I can some way maybe predict what file they're going to try to access, if I can insert some malicious code and then maybe gain control of their Lambda function, right? Possibilities are, I wouldn't say limitless, but there's definitely possibilities there. Really what this is just showing that all these sandbox users' login shells are set to sbin no login. And I'm just scrolling up here, and I'm just showing that the root and ec2-user are the only two users with bin bash. Everything else, in fact, is set to sbin no login. So clearly, Amazon is not expecting anyone but those two users to actually be logged in. Here's an if config-a, just looking at the network interfaces. Again, those questions that curious minds want to know, just kind of going through that list here. We've got three interfaces. We've got a loopback. We've got one that's called vinternal_3, and we've got another one called vtarget_2. Those are on two different networks of a 169.254 network. There's a routing table. Default route points to 169.254.76.6 on this container. I haven't found that to change in my research, but again, I could have just this day, I could have been reusing a container and that hadn't changed. I did find that some of the IPs are dynamically assigned though, so this second command down here at the bottom is just a uname-a, good way to get some nice information. This actual video here is from last October. I haven't had time to go in and remake all this yet, but basically it's showing that the it's Linux IP-10-12-172-177. So chances are, again, I was earlier saying that this is probably running on an EC2 cluster within ECS. That's probably the IP that it's either compiled under on that environment or something related to that. It's running version 4.4.51-40.67 of Amazon Linux for x86 64-bit. Symmetrical multiprocessing, compiled on Friday, June 23rd. Again, this was from last October, so but that being said, if I pulled this in October and it was compiled on June 23rd, that's to say that they're probably, I'm not saying behind on anything, but their release cycles probably are a couple months spread from one another. Assuming that I was toward the end of that, it could have been longer, of course. So I'm going to try to move along because we are at half past already. Just looking at the processes now, those of you that are familiar with containers, you know that there's a very limited attack surface. One of the reasons being is that there's usually only one or two processes running. However, this is the really interesting part of Lambda functions is it is, you probably can't read it, but this line right here is user bin python.2.7, and it's executing a file called var runtime AWS Lambda bootstrap.py. That's when I was like, okay, I think we're getting onto something here. So I think I just make a quick move over to that directory, and I'll probably just skip past the rest of that here, but because I've got details on the RE end of it. But there's the files bootstrap.py and runtime.so. Here I'm just catting bootstrap.py. Just showing you some of them. It's a long file, but it's a Python file. The runtime file is a CPython shared object file, and I think I'll just probably skip past. The rest of it really just shows the environment variables that I've already showed you, but I found it interesting that I was able to get a reverse shell on this and do all this. Again, it's 300 seconds, so once this died at the end, which was about right here, right? It's going to go back, and as all Lambda functions do, they return some sort of a value. So, all right, so let me get back to the presentation now. Take a beverage. So there's the reverse shell. Yeah, sure. No, I did not do that simultaneously. That's a good idea. And I'm doing it through the web interface, so I imagine you'll have to open up 2 tabs, probably. I don't know. That's a good point. I don't know if you can, I imagine you'd be able to execute the same function, but you may have to have 2 different ones with the same code and execute those simultaneously. That'd be an interesting path to take, though. I'll try that. Yeah. Thank you very much for the input. Any other questions? Yeah. Uh-huh. The Lambda function that I wrote was reverse shell code written in Python. So when Lambda invokes, it basically takes my code and executes it. And then so I had that do a outbound connection to a netcat listener I had running on Kali Linux, and that dumps me into a shell, and then I'm logged in. Yeah. Nothing truly innovative in the sense of a reverse shell, but the fact that it's a reverse shell in a Lambda container, that's where I was kind of like, that's kind of cool. So, okay, so we're still in active reconnaissance. I got a lot to talk about still. I'll have to move along. We've got a containerized Amazon Linux. We've got kernel version compilation data. We've got a lot of good information we can work with. There's the network dynamically assigned IPs. We've talked about this. Users, interactive login shells only for EC2 user and root users. You've got the nomenclature. Now the services, again, I want to mention this X-ray because there's some possibilities that I actually can't talk about, but hopefully I will be able to talk about at a future talk. We're looking at X-ray, and then we want to look at like Lambda bootstrapping and execution process. I've started looking at different mount points. This is just kind of a dump of those. You can see the names where they're mounted, the permissions. You'll see that almost every one of them has, no suids, no dev, no atime, read only. The only one you're going to see that has any possibility of exploitation is the one here at the bottom with dev loop 0 is mapped to /temp. That's the only place that we have any read and write. Everything else is read only. This was just a listing of the dev directory, just to kind of give you an idea of what sort of devices it has access to. So if you're familiar with Docker security and it's being, if it's being run in like privileged mode, you'll be able to see the host devices and stuff. So it's a good way to profile that. I had suspected AWS wouldn't be that negligent, and they weren't. Again, they do a really good job at locking this environment down. That sandbox user is non-privileged. From what I can tell at this point, there's no any sort of local privilege escalation, but there's some possibilities, and we'll get to those in a minute too. Okay, so the fun stuff now. So we've profiled this. We know all the different things that how things are configured. We know that we can get those credentials. We have a Lambda execution lifetime of 300 seconds. That simple token service for the session tokens has a default value of 1 hour, but because the Lambda execution is 300 seconds, that's kind of our low watermark, if you will. But what we can do is we can take those credentials, extract them, or export them, right? And then we can put those directly into our command line interface configuration file, which is going to be like tilde-aws/credentials, I believe the file name is called. And we can set those up with key value pairs, AWS secret access key, and again, these are all stale. Don't try to copy them. Try to do something with them. But we can use it with the CLI. We can use it with AWS's API directly. We can also use these in SDKs. What could be the problem with that? So we're avoiding the Lambda execution time because we've now got their credentials, but now what is our other limitation? The 1 hour session time, right? So now we've got to find a way around that. Nonetheless, with these credentials, you can do whatever the Lambda container is granted access to do through AWS IAM. More importantly, all of that is done, as these arrows are showing, under the AWS Lambda user context, or the role rather, right? So it could be you and me all have these credentials, but as it's reported within CloudWatch, Lambda's doing it. So it's very difficult to attribute some sort of an attack that's occurring through Lambda to you or you. The whole non-repudiation, or in this case, repudiable, there's really no way to say with a high level of certainty it was someone that did this. So we've got credential hijacking. Again, limitation, we've got Lambda max lifetime, we've got security token max lifetime. How do we work around this? Well, first of all, we're not going to log in reverse shell. As cool as that is, it still has that limitation. But now we've got session token expiration that we need to concern ourselves with. So we need to be able to renew that some way so that we can retain this persistent remote access that we're wanting. So why don't we stand up an AWS API gateway and just use it through a browser? Simple HTTP gets to the API gateway and then pass whatever commands you want, such as os.environ, as we did earlier, and get all those environment variables. Now all we do is hit the browser refresh, and if an hour's passed, we've got a renewed session token, right? So I mean, maybe we're doing something and we get an access denied because it's expired. Hit refresh, you've got a new one. I think I might have had my slide out of. Oh no, this is just more the. You know what? I got this a little out of order. This was supposed to go a little earlier on with the other the CloudTrail logs, just to showing the context that it's actually executed in. This was the one I intended to show. Again, stale credentials, but if you refresh the page and the session token hasn't been updated, you're going to get the same results. If it expires, you're going to notice a change on this page. So very easy to script this type of stuff, right? Whether it's directly through CLI, or you can set up an API yourself and do it, or you can script something else and use curl and parse it out and do whatever you want with the results. How about we start doing like some sort of reconnaissance within an AWS environment, whether it's in a VPC or it's one of their more a managed service. Well, again, assuming that Lambda function has the proper IAM roles and policies assigned, you can just kind of start going out trial and error and see what it has access to. So, for instance, maybe it's got access to an S3 bucket with, God forbid, personally identifiable information or whatever. Well, we can make that call through the API gateway, have Lambda retrieve it from the S3 bucket, which, fingers crossed, is not public bucket like they so often have been lately. But again, that's a good way around that. Maybe it's a private bucket you can't directly access over the internet, but this is a nice backdoor in to the private bucket, and it's a get object call, and sure enough, if those permissions have been granted, S3 is going to return that. What about network scanning? What about proxying attacks off of this, right? What if we want to do an Nmap scan, or we want to run a Nessus against a host on the internet, but we don't want it coming from our IP? So kind of think of this similar to a proxy, SOC 5 proxy. I want to say Tor, because it's not quite Tor, it doesn't provide the anonymity and security of that, but nonetheless, this is a way to kind of leapfrog or whatnot out to the internet through Lambda from your machine and hiding your identity. And again, all the cloud admin's going to see through CloudWatch, CloudTrail is this Lambda function executing under that assigned role. It's not going to appear to be you. Now, could they maybe go in and start enumerating what source IP address that might be coming from? Sure, they could do that in the API gateway logs that would be logged into CloudWatch. So there's some additional hoops you would have to jump through if you really wanted to hide your identity, but nonetheless, pretty easy way to do it. So we've talked about persistent remote access. We've got about 10 or 15 minutes. Some of the limitations, billing costs. If I'm invoking this over and over again, right? Remember that the minimum billing is 1 millisecond. No, I'm sorry, 1 second. It's 100 milliseconds, whatever. So costs add up as this is going out and maybe doing port scans, or maybe it's pulling down files. Any of the other examples I just cited, that's going to be costing someone money, or if you're doing it for yourself, maybe for just whatever purpose. Right? Maybe it's not even malicious in nature. It's gonna add up. So we also have limitation on the runtime execution. So some of the workarounds we want to look at for that is maybe we can reverse engineer the bootstrap in the runtime environment. We want to ultimately control the data and flow of the runtime execution. So we'll go ahead and pull down that bootstrap py file, but before we do that, I found this really interesting. Is right at the top of it. It's copyright 2013, and this is recent. So roughly 5, 6 something years old now, right? This is when this bootstrap file or function was written. It's pretty lengthy, but it again is accompanied by a shared object file. We'll get to that here in just a second. I'm trying to be very careful with this because it is copyrighted, and yeah, I don't want to piss off Amazon or Jeff Bezos specifically. So what you're going to see here, if you are or are not familiar with Python, basically this line here with the arrow pointing to it, we're importing something called runtime as Lambda runtime, and runtime is the actual shared object file in the same directory. Now that's something important that we'll get to momentarily, but anything that is being called as Lambda runtime parentheses and whatever is going to come out of the shared object file, which again is CPython. So in the main function of bootstrap.py, found something really interesting. AWS goes through 1, 2, 3, 4, 5 environment variables called Lambda control socket, Lambda shared mem FD, memory file descriptor, Lambda log FD, which is a log file descriptor, Lambda console socket, and Lambda runtime load time. Okay, interesting. They go through and delete all those. They cycle through it and delete them. That's the last line. So, like, why would they be deleting those? Well, now this is where, okay, maybe you can see that, good. So a little further down in bootstrap py main function, we've got a call to wait for start. Okay, so again, this is before we're even running, right? This is when it's being invoked, it's bringing it up, it's setting up staging the environment basically for execution. So let's take a quick look at wait for start function. And what you're going to see on the right is lambda runtime.receive start. And remember, that's imported from that shared object file. So what could receive start possibly mean? So I open this up. I know this is going to be really hard to see, and there's not a lot to see per se here, but I did find some interesting artifacts on the file path from which the shared object was compiled. It's a little revealing on maybe some of AWS's or Amazon's development environment. It does say here in the bottom part, I can't point to it that way, there's a string called session here and a string called secret here, which caught my eye naturally, like session and secret. So clearly they're handling credentials, and again, they have to do that as part of the bootstrapping process, so whatever your code is running can execute with those permissions, kind of like what we were talking about earlier. So moving on a little further down, right here at the top, was wait for start that we just looked at. It does some, some setup and configuration for the runtime. But it gets down here to this other function called _get_handlers, and it passes two arguments to it. One's called handler, one's called mode. Well, let's see what get handlers does. Interesting. The first line in it is calling Lambda _runtime dot report user init start. Interesting. Also interesting. They leave this code or this comment in the code. I was like, wow, that's. It just seems to me that they hadn't intended for people to see this. But I don't know. Maybe they want you to know that this is the old way they were loading modules. I don't see why, but yeah. Let's look at what report user init start means or does, because the idea I had with the start stop is that with regards to the billing, is there a way that we can maybe tell Lambda and the underlying infrastructure that the function's no longer running when it really is, right? And get 299 seconds of free Lambda. So again, not a lot to really see here other than what the arrow's pointing at, and it's basically it's returning a value for report user init start plus, I can't even see it on my screen, so small, 104. So it's returning a value, basically. And from what I can tell, that's hooked into Amazon billing. They know when it starts, and then they know when it stops. So the next thing a little below that is called Lambda runtime.report done. And then immediately after that, log info, init complete at epoch, yada, 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 right? Times 1,000. So that's clearly doing something with the billing system. And I went ahead and took, a little look at what that particular function is doing. And again, that last line there, it's report _done plus 186, a little bit different value. So it's reporting something at the beginning and something at the end, the difference of which they're going to bill you for. So then I start thinking to myself, well, how can we gain control of this? How can we manipulate some of it? Well, I did a little research on CPython. Again, new to Python, so I'm like, wow, this is really cool. Evidently, you can tell CPython what Python path you want to use. And I was like, well, AWS, if you recall from some of those, the FAQs earlier, it says create and modify environment variables. So I was like, why don't I just modify the Python path to be a path of my own choosing, i.e. temp or whatever, or we have write capability, and then import our own package, and then we can control, we could basically take bootstrap py, copy, paste it into our own, and then go through and modify it. Follow me, right? So when this is invoked with a modified Python path with the exact same package name, right? I'll show you here in just a sec. It's going to do an order of operation. It's going to pick ours up first and load it instead of the intended one. So some of the hypothetical possibilities. Hypothetical. Again, I want to be respectful of Amazon. I'm just a security researcher, right? But I'm very confident that some of these could actually materialize. I'm just giving you enough information for you to do it on your own for educational purposes only. But we can spoof the Lambda execution time. And again, we're going to get billed for 1 second, but if we can tell it it's already done, we can run it for another 299 seconds for free. We could maybe inject malicious code. We could do log poisoning. Now remember I said, don't forget about X-ray, right? What if we have an admin or some lead code developer, and maybe we want something off of their system? If we can poison the logs or inject some sort of malicious code into the X-ray logs, right? They view that through a web interface in AWS. They're debugging something, put cross-site scripting, cookie hijacking. Now we've hijacked their session and we can do what they do. So some cool possibilities there. And I don't know if Elizabeth is in the room, but she just gave a phenomenal talk on container security in track 1. I suspect she and I are going to be bouncing some ideas off each other tonight. I think there may be a way to escape containers. I'm not really sure, so I want to consult with her on that. But once you can gain execution flow and control, there's, again, the attack surface expands dramatically at that point because you're pretty much in control. So just noting here, these are some of the imports. Again, we would have to name our imports exactly what these were. So if we did decimal.py, modified Python path to point to our own decimal py, we could execute that just as we want. So, all right, we're right on time, actually. Was that been going really fast? So getting here to the mitigations part, access control, study IAM for science. It really is its own science. Places that I've worked that have used AWS very heavily and heavily rely on them have a complete identity and access management team. That's all they do, is they manage policies, and it truly is its own science. And if you really want to lock down your AWS environment properly, you need to understand it very well. Otherwise, you're going to go in and probably use an asterisk just to make life easier, right? Least privilege, need to know, kind of best practice stuff here, right? Is maybe often overlooked as it is. Good housekeeping for your account is always paramount. If you get a user that's new and you give them an account, make sure you're taking those rights away or deleting the account if they either leave the team, leave the company, whatever. Decoupling of that account provisioning is oftentimes very problematic because there are environments where the provisioning takes place perhaps through AD, but when that person leaves and they're removed from AD, their account's still active in AWS. Not naming any names, certain companies. Yeah, and then you can also restrict access for CLI or web interface or web console access, SDK, API calls. You can restrict that access as well. Test and assess the code. Again, this is very DevSecOpsy, a lot of automated deployments, CI/CD pipelines. So back to good old, peer review. If you write some, Lambda code, I need to look at it. It requires a little bit more of collusion, a little bit of a segregation of duties, right? It's just a due diligence measure. Integrate the testing into your CI/CD pipeline, perhaps with some sort of automated SAST testing. There's a number of solutions out there. And then leverage infrastructure as code, which is kind of the hot thing with CloudFormation templates. I'll get to that in just a sec. I think this is the last slide here. So monitoring. In the CloudWatch and CloudTrail, there's going to be certain IOCs. Even though it's being logged as that Lambda role, there's certain, fishy things going on, right? You start seeing a ton of invocations, and it's doing, it's executing a Lambda function called myportscan.py. Probably like, what's this, right? Also, if you've never played around with the Elk Stack, they have a native implementation in AWS. Elk Stack is Elasticsearch, Logstash, and Kibana. It's pretty much an Elk Stack, but you're using VPC flow logs and some other stuff to visualize it. Really neat stuff, but easier way to maybe see some sort of an anomaly, or more traditional means send the logs over to a SOC for more, a little bit deeper analysis and correlation and stuff. And in response, leverage the power of automation in your CI/CD pipelines. You can do alerting instantly to your defer team upon some sort of detection. Maybe you see an IoT or IOC. So many acronyms in our industry. Alert them immediately so that they can take responsive measures to go in and fix it. And I was going to say revert to snapshot, but that's more of a virtualization term. So revert to known good state or known state with a CloudFormation template. So every time you update your environment, your VPC, if you're using infrastructure as code using CloudFormation templates or Terraform or whatnot, you should have had the previous version that was pushed and the previous version of that, right? It's got versioning control and whatnot. So revert back, go in, look at things. If it's the same, you can revert back to the previous and the previous until you're at a known good state, and then, you know, relaunch, so to speak, from there. So that is all I have for today. I want to thank you all again for sticking around late in the day. Available here for 5 minutes for questions. I'll be here the remainder of the evening as well. But thanks very much for listening to me. Cheers. This is to suggest I'm going to continue my research. Hopefully I get some other ideas. And it's also a little bit of play because they've had how many Fast and the Furious now? Like 8, right? So maybe I'll start like versioning this or something. I don't know. Any questions I can answer? Yeah.
Yes. You mentioned sort of flow to create a Lambda container, and I'm curious, since there were so many users that seem to share a container, if you kept at it, I mean, is it possible that one of the users would actually possibly see, like, how is that segregated? I mean, is it segregated? Not that those are the users. Right.
From what I can tell, each time a container is invoked as part of bootstrapping your Lambda function code, right? There's like, this is like Inception. There's so many like layers to this, but each user, that SVX user, has a dedicated container, from what I can tell. So if I launch if I execute a function, it's invoked. That function exists in that dedicated container. If you did, you would get a different dedicated container. You and I are not both running it because, again, then the billing gets kind of quirky. They don't know how to bill to you versus me and stuff like that. So, plus for security. So.
But maybe if you're running the same container, because your process starts with the session key and secret the environment, right? It calls the started it recording at a certain time and it calls
Uh-huh.
It knows how to bill
It knows how to bill
you.
you, right? I guess what I'm saying is, if he's got a different account, like AWS account, yours is 1, 2, 3, mine's 4, 5, 6, right? And we both execute. Let's just say for simplicity, we execute even the same code. You're going to get a different container than I do. Now, once that goes down and we re-invoke, you know, you could get my container, I could get yours for all I know, right? Because there's all those SVX users. I was going down the same line of thinking because I was like, why would they need more than one sandbox user? Why do they need, like 30 of them or whatever they had in there? But from... Those credentials are specific to that AWS Lambda role that's assigned through IAM. Yeah, that's where those are coming from. So everything's in AWS is hooked into IAM one way or another. I mean, that's like the root of all security in AWS. So yeah, if you invoked a Lambda function and that container spun up, if you and I had a shared like AWS account, we would have the same credentials then, but if you're in another AWS account, you would get a completely separate one. Yeah, does that make sense?
Yeah.
Okay, does that answer your question too? Cool. Did everyone hear his question? I'm usually good about repeating it and make sure everyone heard it. Okay, cool. Anything else? I thought I saw a hand over here. No? All right, well, let's go drink some beer and eat some food. Thanks.